Hello everyone, I'm Jacob Bulich, an environmental science major here at JCC, and today I'll be talking about Organic Chemistry 2, chapters 18.1 through 18.2. This will mainly refresh our knowledge of benzene. This chapter focuses on the reaction of benzene and substituted benzenes. This includes the aromatic compounds that can be found in group 4. Some of the properties of benzene are that it is cyclic, planar, has an interrupted cloud of pi electrons, has 3 pairs of electrons in the pi cloud, and is unusually stable. You may be wondering where benzene can be found, and the answer is it's everywhere. It can be found in nature, such as adrenaline, in medications like Zyrtec, commercial products like mothballs or air fresheners or artificial sweeteners, and benzene was also used in the creation of Agent Orange in the Vietnam War. As one can see, benzene is abundant and its form can vary. Now, naming benzene rings gets a little complicated. First, we'll deal with monosubstituted benzenes. These are named by naming the substituent and adding benzene to it. Our first example has an ethyl group attached to a benzene ring, hence why it's named ethylbenzene. This can also be seen in bromobenzene because it has a bromide ion attached to the bromine benzene ring. Some monosubstituted benzenes incorporate the substituent into the name. This chart will help us later on identify what benzene ring we are using in equations. For phenyl and benzyl substituents, the name is just added like the normal substituents would. For alkyl substituted benzenes, when the alkyl group has a name, you name it by the alkyl substituted benzene. Otherwise, you name it as a phenyl substituted alkane. For our first example, it is in the left corner. It is named isopropyl benzene because we have an isopropyl group attached to the benzene ring. However, other example is named 2-phenylpentane because we don't have a name for the substituent. When an alcohol is introduced, we can abbreviate them as AROH. Benzenes react by undergoing electrophilic aromatic substitution reactions, also abbreviated as EASR. As one can see in the example, the E+ is our electrophile and replaces a hydrogen on the benzene ring. I'll get more into this later on. The most common EASR reactions are 1. Halogenation with our halide group, 2. Nitration, 3. Sulfonation, 4. Friedel-Crafts alkylation, and Friedel-Crafts alkylation for number 5. In the example below, in the left corner, shows the mechanism of our EASR. One can see that the bond is breaking and our electrophile is moving in to take the place of the hydrogen. Our intermediate carbocation intermediate is where the double bond breaks and the hydrogen is being forced out from the electrophile. Once the hydrogen is forced out, the electrophile takes its place and the other hydrogen reforms the double bond. This can also be seen in an electron coordinate diagram in the right corner, and it has 2 transition states of the bonds breaking and forming. One can see that it takes more energy to break the bond in transition state 1 than forming one in transit state 2. We will continue these topics in the next videos, and I thank you for listening.